this particular problem, what we have here is an aluminum plate. And this aluminum plate has so and so thermal conductivity. Let us write that K value or whatever given, we will write 160 watt per meter Kelvin, because meter degree centigrade is also equal to meter Kelvin. And the density, meaning rho, is equal to 2790 kg per meter cube. And the Cp is given as 0.88 kilojoule per kg Kelvin. And the thickness is given here. L is represented with L is equal to 3 centimeters at a uniform temperature of 225 degrees centigrade. Suddenly immersed in time t is equal to 0. See, when you have this problem in your examination, this is the keyword. Okay, if you have time in the problem, you have to understand that it is a transient case. Okay, so once you understand that it is a transient case, you can proceed whether it is lump or not. In any given transient problem, next step, once you find that it is transient, you have to check that whether it is lump or not. Okay. So far we have seen what to do if it is a lump. Okay. If it is not a lump, we have to follow some other procedures called as semi-infinite solid and infinite solid that we will be seeing in the next class. So as of now, we will be discussing about the lump system. And it is in a well-stirred fluid maintained at a constant temperature. See this T infinity, because this is the temperature of the atmosphere or the fluid that is around it. And heat transfer coefficient is also given. The H value is given as 320 watt per meter square Kelvin. And is asking you to find time. What is time if the temperature has to reach the 50 degrees centigrade? 50 degrees centigrade. 50 degrees centigrade. So that's what is given in the question. So whatever is given in the question, you have written. The next thing is to find out the Biot number to check with whether this particular thing is a lump or not. Okay. So in this particular thing, you have H with you. Okay, H is given in the problem, and then K is given in the problem. How about this L? Is this L that you're supposed to use here? Can you use this L here?
No.
Actually, this L is LC. Okay, so you have to find out this LC here. LC is nothing but volume by area. Okay, here what is given as an aluminum plate. It's a kind of a cuboid kind of thing. Okay, so simply what you can do is you can write it like L into the other area. You can write that will give you the volume. Okay, and then since it is a plate having sorts of thickness, it will have two areas actually, one on this side, the other on the other side. So 2 into A you can take. So this A gets cancelled. What you have is L by 2. So this LC should be taken as LC will be L by 2, that is 1.5 centimeters. So now I can substitute everything I have with me. I have H with me, it is 320, and LC is 1.5 centimeters. It is 1.5 into 10 to the power of minus 2 by K. The K value is given as 160. So somebody calculate and tell me what is this value. Can you please calculate and tell me?
0.003.
0.003. Good. So this Biot number is less than 0.1. That implies Biot number is less than 0.1. So it can be considered as lump. Lump system is valid So what you can do is you can solve for the time that he is asking you. He is asking you to find out the time, so you can find out the time here. So for that, the formula is, as we have already seen, it is t minus t infinity by t naught minus t infinity is equal to e power minus of biot into Fourier. Fourier, I am writing it here like this. Actually, this Fourier is actually having time. So let me find out the Fourier in first place. Then we can substitute it here. This Fourier is nothing but alpha t by LC square. Alpha t by LC square. So t is anyways unknown that you have to calculate. So you have to keep t aside. And coming to LC, you know LC already. LC, just now we have taken it as 1.5 centimeters, but you can substitute 1.5 into 10 to the power of minus 2 whole squared. You can have it. Right? How about alpha here? Alpha, how to take it alpha? Is it given in the problem? Alpha is not given in the problem. So for finding out alpha, what you can do is the alpha is equal to, as per the definition, it is rho, sorry, it is K by rho Cp. Okay, so that is equal to the K value you have with you, it is 160. And the rho value you have with you, it is 2790 given in the problem. And then you also have a Cp value, it is 0.88. See this 0.88, it is in kilojoule per kg. So you have to substitute in joule. So multiply it with 10 cube here. So then you will have an alpha value with you, which you can substitute it here. Okay, I'm writing the same thing here. 160 by 2790 into 0.88 into 10 cube. So somebody tell me what is Fourier equal to? So the Fourier value, Fourier value will be equal to something into t. Somebody tell me what is that something. Calculate this whole this expression value. You have to calculate and tell. So
0.28.
0.28. 0.28. Okay. So now you move on to the T. The T value is given as 50 degrees centigrade. And T infinity value is also given, it is 25 degrees centigrade. So this is also T infinity, so it is 25 degrees centigrade. It's actually infinity. So now this T naught is also given in question as 225 degrees centigrade. So you simply substitute all the values here. It is like 50 minus 25 by 225 minus 25 is equal to e power minus of biot. Biot you got it as 0.003. Is it? Yes. Biot value you got as 0.003 here. And the Fourier value, it is 0. The Fourier value is 0.28 into time, you got it. So now you do the logarithm on both sides. See, when you do this logarithm, you have to do ln on both sides. It is not log. Okay, where you enter in your calculator, in calculator, you have to enter it as ln, not log. Okay, so that's why I will write it as ln itself here. Ln of 50 minus 25 by 20 to 25 minus 25 is equal to this. You will get it in the product here, 0.003 into 0.28 into t into log e to the base e. This is actually equal to 1. This value is equal to 1. So the t is only unknown here. So that particular t we can calculate here. The t is equal to, we can do it like ln of 50 minus 25 by 225 minus 25 by minus 0.003 into 0.28. So tell me what is t value?
Sir, buyout number 0.03 only, sir. 03 only, sir.
0.03 only, it is not 003. Okay, that's correct. It is 0.03. 0. Yeah. Tell me what is the time value?
247.5.
247.5 seconds. Okay. It has to be measured in seconds. So you will get the value for a time in minutes also. You can convert it into minutes, like you divide it with 60, and all you get it in minutes also. So the point here that I would like to emphasize here is, see, in this particular question, he said that at the center, he is saying, at the center of the plate, he is saying, okay. At the center of the plate means, see, when we say it is lump, everywhere the temperature is same. Okay, the center will reach, the sides will reach, everywhere temperature is same. Everywhere uniform temperature. So when lump is valid, no, at center the same temperature, at the other side same temperature. Everywhere same temperature will prevail. So looking at this word center, you should not get confused. Okay, why you will get confused? You will understand when we go forward. But kindly note that this word center is of an importance to you. Okay, so let's move on to the next question. So this question. So this is a problem given to us here. Okay. Here, what is given is the temperature of the gas stream is measured using the thermocouple. See, one of the very important application of transient analysis is it gives you the sensitivity of the thermocouple. Okay, sensitivity of thermocouple. That is the efficiency of thermocouple, or the ability of thermocouple to measure the temperature accurately can be analyzed using this heat transfer, that is a transient heat transfer analysis. Okay, so that is very important aspect of transient heat conduction, and especially the lump. Okay, so kindly keep this in mind. Thermocouple is very important thing. Okay, most of the times this kind of questions are asked. Okay, ah. So here you have a junction, and this junction is calling it as a sphere, and it has a diameter. You can write down the diameter as 1 meter, 1 mm, and the K value is given as 25 watt per meter Kelvin, and the density is given as 8400 kg per meter cube. CP is taken as 0.4 into 10 cube. I will write it joule per kg Kelvin. The heat transfer coefficient is also given. H is given as what is the value of H? It's 560 watt per meter square Kelvin. This is also given to you. And then he's asking you to find how long it will take. So he's what he's asking, he is simply asking time. What is the time value he is asking? Okay, right. See, how long will it take for the thermocouple to record 99% of the applied temperature difference? So T minus T infinity by T naught minus T infinity value, if you look at, okay, this particular value is actually the temperature that is prevailing now. That is 99% is already reached, so 1% is only left out. So from 100, you have to take out this 99%. So it's like percentage, no? So it is like 1%. That is equal to 1 by 100. See, in some questions, this value is given as 95. Some questions, it can be anything, okay, 80 to 95, any value they can give you. So substitute that value here and then solve the problem. So this problem is getting simplified for you actually, because he is actually giving you the value for t minus t infinity by t naught minus t infinity is equal to 1 by 100. Okay, it makes sense actually. Okay, so if you look at this, see, t minus t infinity is equal to the 1% of t naught minus t infinity. Okay, what is this t minus t infinity? T is actual temperature being measured by the thermocouple. Okay, and the difference between these two is so less that only 1% change is there compared to its initial temperature. So the thermocouple is having 99% of the sensitivity or accuracy, you can say. Okay. So this 99% is a kind of a measure for accuracy of thermocouple or sensitivity or sensitivity of thermocouple. Okay, so kindly keep this in mind. Sometimes, look in the question itself, he'll give you the sensitivity is 99%, the accuracy is 99%. Okay, this is like a practical application of what you are learning here. Okay, the practical application of the concept that we have learned for designing a thermocouple. Okay, whenever you design a thermocouple, you have to use this particular concept of lumped parameter system and apply it. When you apply it, you will understand how much accurate your thermocouple is. Okay, so that's all. So this is what is given in question to you, and what is asking is simply asking you the time. You know that for time t minus t infinity by t naught minus t infinity is equal to e power minus Bayard into Fourier. In order to use this uh, formula, you have to first check whether it is a Bayard number less than zero point 0.1 or not. For that, let us take that Bayard number formula. Bayard is equal to HLC by K. Okay, so the H value is given in the question. The H is known and K is known. Do you know LC here? Okay, D is given here. LC you don't know. Actually, the LC you have to calculate. Okay, LC is actually volume by area. LC meaning the characteristic length. It is the ratio of volume by area. Volume of the sphere. What is the formula? It is 4 by 3 pi r cube. Okay, by what is the area of a sphere? It is 4 pi r square. 4 pi goes, and this one goes. What you have is simply r by 3. Since the diameter is given, you can change it into the diameter terms. In place of r, you can write d by 2. So this will be like d by 6. So this will be equal to the d value 1 mm is given in question. So 1 into 10 to the power of minus 3 by 6. So that's what your LC value is. Okay. Now you can substitute this LC value into this LC value you can bring in here. So now the H value you have to substitute it here. H value is given as 560 in the question, and the LC value is 1 by 6 into 10 to the power of minus 3. The K value is given in the question as 25 watt per meter Kelvin. So somebody tell me what is this watt number value? Please tell me what is the watt number value? Please calculate and tell me what is the value of this particular expression I'm showing in green. Calculate and tell me.
Sir, is it 3.73 into 10 power of minus 3?
Yeah, 3.73. Yeah?
Yes, sir.
Is it?
Yes, sir.
Yeah, 3.73 to 10 to the power of minus 3.
3. Yes,
Okay.
sir.
And this value will be less than zero point 0.1. So what you can say is Wyatt number is less than zero point 0.1. That will imply that lump is valid. Okay. Since the lump is valid, you can use this formula very comfortably. Okay, this formula. So Bayat, this side, Fourier, you have to find out. Fourier is equal to alpha t by LC square. Alpha is nothing but k by rho Cp into t by LC square. Okay. K value is given in the question, it is 25, and the rho value is also given, it is 8400, 8400. The Cp value is also given, it is zero point 0.4 into 10 cube. This value is given as this here. Okay. Substituted that. Anyways, time you don't know, time value is unknown to you. Time by the LC square is 1 by 6 into 10 to the power of minus 3 whole square. So now you tell me what is Fourier now. It is something into t. Yes, please tell me what is the value of this expression. Yes, Tarun, you tell me. B2. Tarun, are you there? Roll number B2. You are not there. See, I'll call out your names or the roll numbers. You have to respond. Hmm? Unless you respond, unless you do this particular problems along with me, you will not learn actually. So kindly learn along. Okay, you need not prepare separately. Once you can write your notes properly, that notes itself is useful for your preparation. Okay,
Sir, is it 267.8 into T?
267.
I did twice, sir.
What?
267.85, sir. Is it that correct one?
I don't know. Let's try. 267.85.
85.
Okay, let's try this. Just t minus t t by t naught minus t infinity is equal to e power minus bar 4 here. So this value is given as 1 by 100 for us, and this is equal to e power minus of the biot is, what is the biot value that we have got? It is 3.7 into 10 to the power minus 3. The Fourier value is 267.85 into t. So uh, have ln on both sides, ln 1 by 100 is equal to minus 3.7 into 10 to the power minus 3 into 267.85 into t. Tell me what is the t?
4.65.
4.6
Huh?
seconds.
What is
4.
the value? 4.6 seconds is right answer. Okay. So that's what he's asking to find out. Right. So that's all from this particular problem. Let's move on to the next problem. And this is a problem given here. There are about 5 questions in this. So let's solve them. Right. So this problem is saying that there is a component, die-cast component, and it has a mass. It is giving you the mass here. Let us write the mass here. Mass is equal to 1.2 kg is given. The density is also given. It's 7150 kg per meter cube. The area is given as 0.075 meters square. The thermal conductivity K is given as 95 watt per meter Kelvin, and then 385 joule per kg Kelvin is given. So it will be Cp. 345 degrees centigrade is given. Let's write this 345 degrees centigrade, and it's giving you 20 degrees centigrade. You can understand that this 20 degrees centigrade is actually T infinity. With the convective heat transfer coefficient, the H value is saying that it is, the H value is 56.8 watt per meter square Kelvin is given. It is asking you to find out that, let's solve the first one first. The first question what is asking is the temperature of the part after 5 minutes. What is temperature is asking, and time he is giving you. Time is 5 minutes. You have to take it in seconds. 5 into 60 seconds. Okay. So you have everything with you in this question. You have to solve for it. So this temperature he is asking. So this will obviously be T naught, that is initial temperature. So as per the formula, the T minus T infinity by T naught minus T infinity is equal to e power minus Biot into Fourier. You know this. So before you use this formula, you have to check whether the Biot is less than zero point 0.1 or not. So you have to check that Biot is equal to HLC by K. H and K are given. LC you have to find out. The LC value is equal to the volume by area. So here, the volume by area, whether you will consider it for a sphere, you will consider it for, you know, the slab, or which one will you consider here?
Slab, I guess.
Hmm?
Slab, I guess, sir.
Slab? No, for slab only. What is the shape of it?
Rectangular.
Rectangular? Slab need not be the rectangular. It can be circular also,
Directly
is
mass
it not?
by
Huh?
mass
See,
by density, sir. Directly.
the important part here is she has given you the mass here. Okay, so since it's given a mass and you have a volume here, what you can do is volume is equal to mass by density you can take. Okay, and the area value anyways he has given you. Okay, the area value is given to you in the problem. Here it is. So this way you will calculate the LC here. This way you will calculate the volume by area here. Okay, volume to area ratio. This is how you will find out, right? So the mass value is given as what? 1.2 kg, 1.2, and the density value is 7150, and the area value is given as 0.075. So somebody tell me what is LC value?
0.002.
0.002. You take as 2.24 into 10 to the power of minus 3. Okay, that will be more accurate. LC is equal to this one. Right. So what is the H value that is given in question? It is 56.8. It is 56.8 into the LC value is 2.24 into 10 to the power of minus 3 by the K value. The K value is 95 given. Substitute that 95 here and tell me what is the Biot number value.
1.3 into 10 power minus 3.
1.34 into 10 to the power of minus 3. So the Biot number is less than zero point 0.1. Therefore, lump is valid. Lumped parameter system is valid. Okay. Now that you know Biot number value, you should also know what is the Fourier number value. The Fourier is equal to alpha t by LC square. Okay. Actually, this particular t is also given in this question, so you can simply substitute that also here. The alpha is k by rho Cp. It is not rho Cp, okay? It is k by rho Cp into the time by LC square. And the k value is 95. The rho value is 7150. 7150 into the Cp value. See, 385 is given in question, isn't it? Yeah, 385. And T is 5 minutes. So it is 5 into 60 seconds by the LC value. Just now we have found it out. It is 2.24 into 10 to the power of minus 3 whole square. Don't forget this square. Many times people forget this square while substituting in the calculator. Okay, now tell me what is Fourier number value.
2063.39.
2063, you mean, right?
Yes, sir.
69. Yeah, that's the Fourier number value. The t minus t infinity by t naught minus t infinity is equal to e power minus by r into Fourier. Fourier. So everything is known except this t. This t is unknown. You can substitute all those values here. So t, the t infinity value is 20 and t naught is 345 minus 20. Okay. This 20 and 345 are here. Okay. 345 and 20 we have used. We have substituted them here. And e power minus the Bayard number value, you have found it out as 1.34 into 10 to the power of minus 3 into the Fourier number value is 2063.69. So only unknown is t here.
Sir, is it 41?
The t value is 41 degrees centigrade. So that's what he's asking you to find in your first question. So you're done with this. Okay. So first question is done. So let's move on to the second question now. What he's asking in the second question, he's asking you to find out the time in the second question. Okay, he has given you the temperature here. It is asking you to find out the time. Okay. So how do you find that? So for that, what you have to do is you have to have the Fourier number here in a different way. So the Fourier number, the second question is asking you to find out time if T is equal to 50 degrees centigrade. Previously, it was 41 degrees centigrade in the previous question. Now, what is the time required for 50 degrees centigrade? He's asking you. So it is like 50 minus 20 by 345 minus 20 is equal to e power minus Bayard into Fourier. But here the Fourier number will change because time is not 5 minutes now. It will change now. So you have to find out the Bayard number, the Fourier number in a different way here. So the Fourier number is equal to alpha t by LC square is equal to k by rho Cp into time by LC square. LC square. So substitute all the values and you will get this particular Fourier number in terms of time. Okay. The simple way to do it is you have this 2063.69 now. You divide it with 5 into 60. Then you will get it. So you tell me what is this value. The Fourier number is something into t. Tell me that.
6.87.
6.87. 6.87 into t. Get. So we substitute this Fourier number and Bayard number into this. This is equal to e power minus of 1.34, right? Divided by minus 3 into the time. That is 6.87 into time. So from this, you will get what is t. T
Alpha
is
157.
somebody told me the value. Repeat it.
157.
157.
1.
No, it is about 200, 250.
256.78
256 point
78 seconds.
7 seconds. That's what your time is. Yes, that is your time. Let's move on to the next question. That is the time constant he is asking. Okay. Time constant means what? The third question is asking me to find what is the tau. Tau c. See, tau c means what? In Biot into Fourier. Okay, you put out t, the remaining part will be your time constant. That is Biot is HL by k into the Fourier is alpha t by LC square. This t you put it aside, and this part will be a tau c. Okay. Simply put, it is the product of 1.34 into 10 to the power of minus 3. And this alpha by LC square, you have just found it out, it is 6.87. In the previous question, we have done. So the tau c is equal to this. Tell me what is tau c? No, no, it's actually 1 by tau c. This 1 by tau c. So we get tau c in so many seconds. This is actually measured in second inverse. This is second inverse. Here you get seconds. Tell me.
Sir, is it 108?
108.6 seconds. Okay,
Yes, sir.
right. So you're done with the third question. Let's move on to the fourth question now. The fourth question here is the value of convective heat transfer coefficient, the H value he is speaking about, up to which the lumped parameter model can be used. The H value up to, so let us consider the H value is unknown now and do this. Okay. The fourth question, you don't know the H value. Okay. So the HLC by K is equal to 0.1. Let us take, because till here yours is a biot. And once it reaches is equal to 0.1, it is not, sorry, till less than 0.1, it is lump. It is a lump. Once it crosses this, it is not a lump. So that's why we are using this is equal to here. So H, let us say, is unknown, and the LC value is known to us. What is that value? It is 2.24 into 10 to the power of minus 3 by K. The K value is, this is the LC value, and the K value is 95. K value is 95 is equal to 0.1, and H is unknown. Tell me what is the value of H.
Sir, is it 4241?
It is 4241. Nah? Yeah, it is 4241 watt per meter square Kelvin. Okay, if the H value crosses beyond this value, you cannot say that it is a lump. Okay, if it is less than this, you can call it as lump. Okay, so that's the fourth question. Then we'll move on to the fifth question. The volume by area ratio after which the lumped parameter model can be used. Okay, now let us say that LC is unknown. Okay. Previously we said H is unknown. In this question, LC, LC is nothing but volume by area ratio is unknown. So here HLC by K is equal to 0.1. Let us take, and the H value is given as what? The H value is given as 56.8 in the question. Let us use this 56.8. 56.8 into the LC by K is 95 is equal to 0.1. Tell me what is LC value now?
0.16.
0.1672.
That tell me 16 1672 meters. So if your LC is crossing beyond this value, you cannot consider it as a lump system. Okay, so that's all for today. Hope you have understood all these problems.